Hello guys, hello everyone, welcome to my channel. Today we are going to learn about how to design one-way slab of effective span 6 meter in a numerical way. So let's start. Given support width of 230 mm, live load of 4 kN per meter square, floor finish 2, and slab is used for pedestrian river crossing, which means we have to design slab for bridge. So step 1 is you need to mention all these things so that it will be easier for you to solve this numerical. So effective span LC is equals to 6 meter, support width 230 mm, floor finish 2 kN per meter square, and live load 4 kN per meter square. So let us adopt concrete strength of M20, which is the ratio of 1 is to M20, 1 is to 1.5 is to 3. 1 cement, 1.5 sand, and 3 aggregate. And we are taking a rebar of Fe415. There are two types of rebar available in the market, Fe415 and Fe500. Fe415 is tourist steel and Fe500 is TMT. In this case we are using our tourist steel rod, so Fe415. Step 2 is the determination of slab depth, which is capital D. So D required is given by L effective by alpha, beta, gamma, delta, lambda. This is the formula you need to remember, or it is also available in code IS 456. So our L effective is 6000 by our alpha value of alpha is 20, beta 1, gamma 1.5, 1 and 1, which is also available from code. And by solving this we get 200 mm. So let us adopt D a bit greater than D required. So capital D is equal to 250 mm. We increased our D required by sometimes. So let us take D as 250 mm. So D provided is equals to D minus effective cover. So let us take our effective cover in slab to be 30 mm. So D is 250. 250 is from here. 250 minus 30 mm is 220, which is greater than D required. D required 200 mm. So it is okay. Now step 3 is determination of moment resistance. Moment resistance of our slab. So self weight is given by gamma concrete into D, and we know gamma concrete is 25 kilonewton per meter cube into depth. Here 25 kilonewton per meter cube into depth is in meter. So meter 1 meter cancel, so only meter square will remain. So gamma concrete into D self weight is equal to gamma concrete into D is 0.250, which we adopt as this. So 0.250 is equals to 6.25 kilonewton per meter square is self weight. Also similarly live load is 4 kilonewton per meter square and floor finish is 2 kilonewton per meter square. So our total moment is total weight is given by 12.25 kilonewton per meter square. Now factored load W4 is 1.5 times 12.25. We should always assume a factor of safety. So 1.5 times W total is 18.375 kilonewton per meter square, which can be also designated as 18.375 kilonewton per meter width of the slab. Now mu is given by W into L effective square by 8. W into L effective square by 8, where W is obtained from this factored load 18.375 into L effective. Our effective span is 6 meter, so 6 square divided by 8, and on solving this we get 82.687 kilonewton per meter width of the slab. Now our mu limited moment of resistance is 0.138 FCK into BD square. This formula can be obtained from code IS 456 2000, and on keeping the value 0.138 into FCK is 20 characteristic strength 20, and B 1000 into depth, small depth is 220. How is B 1000? Because we take per meter width of the slab. So per meter means 1 meter, and from that 1 meter is 1000 mm. 1000 mm into D is this, D provided. So our mu limited is 133.58 into 10 to the power 6 Newton per mm, which is less than mu. Our mu is 82.687. Our mu is 82.6.7, and our mu limited is 133.58 into 10 to the power 6. So our design is okay. Now let us go towards step 4. Step 4 is determination of AST, area of steel. So the formula is given by mu is equals to 0.87 Fy AST into D 1 minus Fy AST by FCK BD. This is also obtained from IS 456 code, which is here. IS 456 code Annex G in page number 96. This is our desired formula. Desired formula mu is equals to 0.87 Fy AST D 1 minus AST into Fy by BD into FCK, where D is effective depth, Fy is characteristic strength of reinforcement, AST area of tension reinforcement, FCK characteristic compressive strength of concrete, which we take as 20 in our case, and mu limited is limiting moment of resistance of a section without compression reinforcement, and XU max is limiting value of XU. So after writing this formula and solving this equation, we will get AST is equals to 1170.133 mm square. Now AST minimum is always given by 0.12% of BD, which is also obtained from code. 0.12 into B means, as I have said earlier, 1 meter per meter length. So 1 meter is 1000 mm into D is 220, and then solving this we get 264 mm square as our minimum area required. So AST minimum, AST is also obtained. Now spacing between the rebars, it is given by formula 1000 into small AST by capital AST. 1000 into pi into 10 square by 4. Let us take diameter of AST as 10 mm. So 1000 into pi into 10 square divided by 4 upon AST, which can be obtained from this AST of rebar. So on solving this, the spacing between the rebar is 67.120 mm. So we need to keep the two rebars at a spacing of, let us say, 67.120 mm, or inside you can take 60 for usable purpose. Now we need to calculate the main bar and distribution bar. So for distribution bar, provide 10 mm diameter rebar and spacing S is equals to 1000 into pi into 10 square by 4 into AST 264 AST minimum, which can be obtained from this. So on solving this, spacing is 297.49 mm square. So as a conclusion, let us provide 10 mm diameter bar at 60 mm center to center as main bar. This 60 mm center to center as main bar. Always take a bit minimum. And also provide 10 mm diameter bar at 280 mm 297 as common answer. So we have taken 280 mm as distribution bar. So in figure it can be simply done as this. This is effective length of 6 meter. Minimum, and the main bar should be always in short span. and distribution bar, and it should always keep at first, because if we keep distribution bar or longer section at longer section at first, then there will be a chance of deflection in this way, and it will deflect throughout. Sagging or hogging moment will appear. So at first you need to keep rebar at shorter span, which is also called as main rebar. So this main bar is kept at 60 mm center and diameter is 10 mm, and distribution bar, it is kept at 280 mm center to center and 10 mm rebar. Well guys, this was for today. Thank you for watching, and I will be solving another mathematical problem related to slab. This is one-way slab. In my next video I will post about two-way slab, so please don't forget to like, share and subscribe, and comment as well, and also give us feedback whether you like my video or not. Thanks for watching.